All right, let's try a little thought experiment. What happens when you mash up the world of ultimate luxury with, cutting-edge space travel? Just picture this. You're re-entering Earth's atmosphere, and instead of a regular old heat shield, you're behind a flawless, shimmering diamond. It's a wild idea, so let's dive in and see what the physics actually says about it.
So here's the big question we're tackling today. Could you literally take a heat shield tile, maybe one from a SpaceX Starship, and transform it into one single perfect diamond? I know, it sounds like something straight out of science fiction, but the answer is buried in some very, very real science.
Okay, so to figure out if our diamond heat shield is even possible, we have to go back to basics. We gotta understand the recipe. How are diamonds made here on Earth? Well, it turns out nature, and now industry, has a very specific formula.
The main way we create synthetic diamonds today is through a process called high pressure, high temperature, or just HPHT for short. And it's exactly what it sounds like. We're basically trying to copy the insane environment deep inside the Earth's mantle. You take a bunch of carbon atoms, squeeze them under immense pressure, and bake them with incredible heat until they stop being chaotic and just snap into that perfect, super strong crystal structure we call a diamond.
So it really just comes down to two main ingredients: absolutely crushing, unbelievable pressure and extreme heat. We're talking something like 1500 degrees Celsius. But honestly, for this thought experiment, it's the pressure that presents the truly mind-boggling challenge.
So yeah, let's zero in on that first ingredient. Just how much pressure are we really talking about here? It's a number so big it's almost hard to wrap your head around.
Get ready for this. The magic number is around 800,000 pounds per square inch. That's PSI. That is the force you need to apply evenly across every single tiny square inch of your material to force those carbon atoms to line up and become a diamond.
But okay, what does a number like 800,000 psi even mean? It's one thing to see it on a screen, but it's another thing entirely to really feel the scale of that kind of force.
This quote right here does a fantastic job of putting it in perspective. Just think about the normal weight of the air all around you right now, the pressure you feel just standing there. Now imagine multiplying that feeling by 50,000. That's the kind of pressure we're trying to create. It's a force that belongs deep inside a planet, not something we just build on the surface.
Okay, so we have our recipe. We know the insane pressure we need. Now we need our piece of charcoal, I guess. So let's turn to our candidate for this transformation, one of those hexagonal heat shield tiles from a SpaceX Starship. We need to know its size to do the math.
So a standard Starship tile is this cool hexagon shape, about 9.5 inches across. But the crucial number, the one we really need for our calculation, is its surface area. The total area we need to press down on is about 78 square inches. So remember that number, 78. It's about to become very, very important.
All right, this is the moment of truth. We have the pressure we need per square inch, and we have the number of square inches on our tile. So let's put them together and see what kind of monster machine we'd actually have to build.
Here's the setup. It's actually pretty simple multiplication. You take that 800,000 pounds of force for every single square inch, and you multiply it by the 78 square inches of our heat shield tile.
So what's the final answer? What's the total, absolutely mind-boggling amount of weight we'd need to put on top of that one tile to forge it into a diamond?
62,400,000 pounds. Just let that number sink in for a second. That is the raw force we need for just one tile. But, okay, let's put that in a unit that's maybe a little easier to picture. That's 31,200 tons. Now, to give you some perspective, that's like stacking more than 3.5 modern US Navy destroyers and balancing all of that weight on top of a single tile that's less than 10 inches across. That's the weight our machine would need to create.
So, after a number like that, you can probably see where this is going. As cool as a diamond heat shield sounds, for now, it's pretty much just an engineering fantasy, and the reason why really just comes down to a problem of scale.
I mean, look, the HPHP presses we have today are amazing, but they're built to focus all that pressure on a really tiny area to make little gems for jewelry or industry. The machine we'd need to exert 31,000 tons of force over a 78 square inch area, it would have to be monumentally huge. And here's the real kicker. The press itself, the very materials we'd use to build the anvil doing the pushing, would probably fail under that colossal stress.
So really, the bottom line is this. We understand the physics perfectly. This isn't a science problem, it's an engineering problem. The forces we're talking about are just too massive for today's technology.
We simply can't build a machine that's strong enough to withstand its own power at that scale. And you know, that just leaves us with one last, kind of awe-inspiring thought. If it takes the weight of a naval fleet to even theoretically create a single diamond tile, just try to imagine the incomprehensible forces at work deep inside our own planet, shaping not just little diamonds, but the very geology of entire worlds. Makes you wonder what other impossible materials are being cooked up right now, deep beneath our feet.